It's running along at a good clip in there. Okay, so here's version 2.0 of the electric static motor that I'm going to be testing. And it's very simple in design. The only reason it's in this enclosed housing is to protect it from the wind. And a quick update on the crystal cells. This morning it's in the teens. And that's Fahrenheit, so it's just been freezing cold. These things are frozen solid. But they're working here. And these, I'm going to, as soon as it warms up, it's just been too cold to build these lately, but I'm going to build the rest of these to make the 15-volt crystal cell pack. Okay, so this is version 2.0 of the atmospheric electricity powered electrostatic motor. And I've got the line running up to my hexacopter. And man, it is just running this motor along. Nice. Look at that. Very, very smooth. So, very encouraging results so far. Same setup as before. I have the sky, which is the positive, coming into this side. It's not actually touching anywhere in the electrostatic motor. And then I've got the negative ground connected over here. So positive from the sky, negative to the ground, and that motor is just running along just fine. You can see the hexacopter still climbing a little bit. Now the reason I'm using the hexacopter, folks, is because it's cheaper than helium and other things for me at this point. I have a GPS lock on my hexacopter, so I can just park it in the sky and do tests. And very, very fascinating. So that's it, running along. So yeah, the next step, I want to create a small transformer, a step-down transformer and a spark gap, and see what I can do with that. But anyway, very encouraging. So, I just want to demonstrate my electric static generator. At this point, I don't own a Van de Graaff generator. I haven't built anything like that. So, I'm using a piece of PVC pipe and a silk scarf. That's all you need to test electrostatic motors. So, I've got the ground line coming down here to the ground. The positives up here to this little wire, which is acting as a collector. And then the motor. So, let me just show you how easy it is to create some electrostatic electricity to test the motor. So, I'm just going to rev the pipe here, and you can see almost instantly that motor starts spinning. And that's a wireless electrical field coming off the PVC pipe and being collected and brought down to the motor. So very simple way to create some static electricity. PVC pipe, piece of silk cloth, and you've got all you need to test electrostatic motors. So there's been some discussion in the comments on the YouTube video threads about whether this is being powered by radio stations and their electricity they broadcast through the air. So unless your radio station is broadcasting with Van de Graaff generator with electrostatic electricity, it's much more likely that it's the naturally occurring atmospheric electricity that Benjamin Franklin tapped into with his kite that's been well documented and well tested through the years. So just wanted to make a point on that. You can see the construction of this particular motor. There's 4 strips of aluminum foil. I'm using aluminum heating duct tape. It's adhesive on one side for that. So I just cut and glued down 4 strips along the rotor. I've got these little points cut in the aluminum foil on this side and this side. And the whole thing is making no contact at any points. So this rotor is completely free spinning. There's no contact on either of these strips. But if you read any of the books that talk about electrostatic motors, you can come up with all of these basic building principles. Okay, so one other quick book review. Since my last video, I ordered another book from Amazon, and this one's called Electrostatic Experiments by G.W. Francis. And the reason I got this book is I was researching Dr. Oleg Jefemenko, and he edited this book. In 2004, you can read here about what he did in the edit. This is a very rare book, and it's really hard to get a hold of, but he went ahead and he just clarified a few of the words. Some of the words that are used in this book are no longer used in the English language, etc. So he did a few things to bring it up to date, but this book, folks, this is probably by far my favorite book out of any of the books I currently own on electrostatics. Really fascinating stuff here. A lot of this stuff I've never seen or heard of in any other book, so really enjoying this particular book. There's a whole chapter in this book, and I didn't realize it when I bought it, but there's a whole chapter in here on atmospheric electricity. So very pertinent to my current research. And this book is written in a very old style of English. And it's really fun to read in some ways because of that. But Dr. Oleg Jefemenko tried to clarify anything that'd be too misleading. Let me just read a portion of this book here to give you an idea of what you're getting into with this book. And this really cracked me up. I thought this was hilarious. In this book, they call electricity a fluid a lot of times, and a electrical experimenter or an electrical engineer a philosopher. So I'll kind of give you a heads up. All right, so let me just give you a quick reading of a paragraph here and show you the quality stuff that's in this book. And the way this is written is really fun to read today, looking back on it. So check this out. This is talking about the electric kite, harvesting atmospheric electricity with a kite. And it says here, no philosophical instrument is more simple in form and easy to construct than the electric kite. Yet no one needs more care in its management. To fly it when a thunderstorm is approaching would be attended with the greatest danger, unless every precaution be taken. In this state of the atmosphere, the rising and lowering of the kite requires the utmost circumspection. To let the string wind out immediately from the ball in the hand, making thereby the body part of the conductor, is too venturesome. The string should pass over and touch an iron railing, or through a ring fastened to a metal rod driven deeply into the ground, whilst the person who holds it is placed upon a dry, glass-legged stool, or otherwise insulated, for example, upon a pile of books or paper. When upon a sufficient height, the remainder of the string may be fastened to a key, and the operator is then able to remove himself to a safe distance. It is advisable also that the electric fluid should never be introduced into a dwelling house, for a thunderstorm is a terrific agent to tamper with, and once invited into our house, may occasion dreadful damage ere it be allied. Quality stuff here, folks. And man, those old-time experimenters, those guys were a whole nother league in an adventurous spirit and a very inquisitive mind, and they tried all kinds of stuff, and really enjoying this book. So just thought I'd mention that. Check it out, Electrostatic Experiments. I'll include the link to this book and anything else at laserhacker.com. I'll go ahead and add to my last post on atmospheric electricity, include the link to this book, and maybe some stuff on how to build electrostatic motors. And like I said earlier, I'm going to go ahead and try to come up with a design for a 3D printed electrostatic motor. I'm going to start to research the antennas. I've heard reports of electrostatic motors running from 20-foot antennas. So rather than just running a line up in the air on my hexacopter with no antenna to speak of, I'm going to go ahead and start creating some really needlepoint arrangements on an antenna and see if I can't bring in the atmospheric electricity at a much lower elevation with some PVC pipe antennas. So anyway, I'm going to keep experimenting with all this. As soon as it warms up, I'll get back to building the rest on my 15-volt crystal cell. It's just been too cold lately, so let's all keep experimenting and sharing what we find.